This is Unit 3 on Graphing, Lesson 2, Slope, Intercepts, and 3 Forms of a Line. In this lesson, we are going to be finally connecting the idea of equations to graphing, or pictures of these equations. So with this, you'll be able to explain that every point x and y on a graph of an equation represent values x and y that make an equation true. You can verify that any point on a graph will result in a true equation when the coordinates are substituted into an equation. You can identify any of the 3 forms of linear equations, which are standard form, slope-intercept form, and point-slope form. You can define slope and identify its 4 types. And finally, you can also define what a y-intercept and an x-intercept is. Your first vocabulary word is slope. Slope is the ratio of vertical change or rise to its horizontal change or run between 2 points on a line. Slope is called the rate of change. In other words, a slope is described as the steepness of a line in a coordinate plane. You can measure the slope of a hill, mountain, road, or roof. So let's think about slope for a minute. How does the slope of a road affect a person's driving? Well, think of if you had a very steep slope. So if a slope was high, or greater, I don't know how to say, slope is steep, or high, a larger number, let's say, then you can expect you would be going, if you were going downhill, you would go very fast. Downhill. If you were trying to go uphill, you would go probably pretty slow. Sorry for the dog. If the slope is lower, then I suppose your brakes wouldn't wear out as bad. If you were trying to go hill, you could maybe, if you were trying to go downhill, if you're going uphill, you could go up much faster uphill if it wasn't as steep. So it depends on if you're going uphill or downhill. How to write that, let me see. Here you go, I rewrote that. If you're going downhill on a steep slope, you would go fast, uphill, slower. So what kind of ski slope would a beginner skier use? Probably a lower slope or a small slope. So that they wouldn't go down as fast and they can, be able to stand steady. So with those ideas in mind, there are 4 types of slope. There are positive slope, when a line goes uphill from left to right. To help you see that the line is going uphill, one thing I recommend you do is write your name on the line. So if you write your name on the line, now I wrote my name, Stacy, notice that my name is going uphill. So that means that line has a positive slope. The opposite would be a negative slope. If you see your line going downhill from left to right, write your name on it and you can see clearly that my name is going now downhill. It's a negative slope. So you can have positive slope or negative slope. But as I said before, there are 4 different types of slope. So what are the other 2? Zero slope. Now, when I talk about slope with students all the time, I always like to tell the story about my husband when he built this slide in our backyard. We had a very steep slope. So when he built the slide, I first told him, I was like, you can't build that slide that way. And he's like, yeah, I can. He just altered the plans a little bit. And he says, who says you can't? And I said, well, it would have a slope greater than 1. And of course, being a math teacher, he just shook his head at me. I said, what do you mean it have a slope greater than 1? Well, the slope of the slide would be so steep that these kids would go down too fast in it. And I'll give you kind of an example. Versus the slide, the perfect slide would be the slope of 1. So if you had a perfect slide slope of 1, the kids could go down at a good pace, but they'd be happy when they got down to the end. But a slope greater than 1, or steeper slope, the kids would be going down pretty fast and probably land hard. And that was what happened at our house. One day I had a girl that I was babysitting, and as I was catching all the kids at the bottom of the slide, I hear her say, "Hi, Daddy," as her dad arrived at our house, and I turned around and looked, and suddenly she went down the slide without me catching her, and she fell down to the bottom real fast. And it hurt, but she was alive. So a zero sloping slide would be a real flat slide. In fact, it'd be so flat that if a kid tried to slide on it, they wouldn't go anywhere. And the kids would be pretty unhappy, but they wouldn't be dead, right? Because they're not going anywhere. So a slope of 0 is a horizontal line. When you see a horizontal line, you do say that the slope is 0. You don't go anywhere. The opposite of that would be a vertical slide, or undefined. So a vertical line has an undefined slope. It says it's undefined, or you say that it's no slope. Think of a slide. If I had a slide that was straight vertically up and down, the kids wouldn't be sliding at all. They would be falling. And if they fell from a great height, then they probably wouldn't be alive, unfortunately. So this isn't falling, or this falling is not sliding. Ouch, there's no slope. So hopefully my little faces there will help you remember the difference between 0 slope and no slope. So let's practice these. Looking at each line, let's label them. Are they negative slope, positive slope, a slope of 0, or undefined? In the first question, there's the line. If you write your name on the line, you notice that you are going uphill, so this is a positive slope. In the next line, if I write my name on it, you notice that I'm going downhill, so it is a negative slope. In the next line, here we have a flat line. I'm not happy. Oops. So this is slope of 0 because I don't get to go anywhere. But on this last line, the vertical line, I got my little X's on my, really sad because I'm dead, is a undefined slope. Sorry, there we go, undefined slope. To help you out, the equations for these lines for negative slope, positive slope, slope of 0, and undefined, it's also important to know that a positive or a negative slope will have the same equation, y is equal to, but then you'll have a positive x value. For a negative slope, you'll have a negative x value. For a slope of 0, because there are, you'll have no x's in your equation at all. You'll have no x's in your equation at all, and you'll just have y's equal some number. Where in these other two, you might have plus or minus some number, In the undefined slope, you won't have a y value at all. It'll just say x is equal to some number. So if you see an equation with no y's and just an x, you know you're talking about a vertical line or a line with no slope. Where if you have just a y and no x's, that's that slope of 0. Next word is intercept. An intercept is a point where someone or something is stopped along the way from one place or another. It's like intersect and intercept. So the y-intercept is where a line will cross or intersect the y-axis. The x-intercept is the point where a line crosses the x-axis. So these are called x and y intercepts. So in this example here, the blue line, you notice that the y-axis is this line going up and down, and you notice our blue line intersects right here. Its intercept is a point, and that's important to know that it is a point. I have so many students that just say, if the question asks, what's the y-intercept, they'll say 4. The y-intercept is a point when x is equal to 0. So when x is equal to 0, what is y equal to? Well, 4. So you write the coordinate 0, 4. The x-intercept is the point where it crosses the y or the x-axis down here. So when y is equal to 0. When y is equal to 0, x in this example is equal to -3. So let's take 2 minutes to reflect on the following questions. How are x and y intercepts different? Well, x-intercept is on the x-axis and y-intercept's on the y-axis. So how are they different? Oops. Well, it's the place where one of them is equal to 0. The x-intercept is when y is equal to 0, where the y-intercept is when x is equal to 0. So how are they the same? Well, they both are at a point when one of the coordinates is equal to 0. Equations of lines can come into 3 different forms. They can all represent the exact same line. It's just we have a name for their forms. Slope-intercept form is y equals mx plus b. You might want to chant that several times. This is the most popular form of equations of a line when we're graphing. It's the one that's most useful for graphing. So we're going to be using this one a lot. The m value, m represents the slope of the line. Now if you're trying to wonder, well, why did they use the letter m for slope? It's because the guy who came up with this was in Latin, which m stand for montagna, or mountain. So that's where the slope came from. Letter starts with M. The B value represents the y-intercept. Again, why the letter B? Well, I can't tell you why, but one thing I can tell you is think of B as where a line's going to begin when we get to graphing. So this could be an addition or subtraction. Standard form, which many of your problems that you've been used to so far been working with, is ax plus or minus by is equal to c, where a and b are coefficients or the numbers next to your x and y value, and c is your constant. In this form right here, we cannot graph. So that's why it's very important that we understand the slope-intercept form. We're going to be learning in future lessons how to change an equation from standard form to slope-intercept form. A third form that you might see is called the point-slope form. It's not as common on the ECA, but we do need to show it just in case they do give it to you. The actual equation for point-slope form that you'll see like on a formula chart that you'll be given for the ECA is y minus y1 is equal to m times the quantity x minus x1. y1 and x1 represent points, a point that they're going to give you. This equation right here, or this formula, uses the negative sign. Whenever you see a formula with a negative sign, it means the opposite of. So whenever they give you the 2 points to plug it or use this equation, you would have to use the opposite sign. So for that reason, when I rewrote it, I put a minus with a positive on top or a minus with a positive on bottom to let you know it's the opposite sign. Your M still represents the slope, or how steep the line is. You may be asked if a point is a solution to an equation. If they give you a graph, this is real easy. You just plot the point, and if the point is on the line, then it is a solution. So let's find 3, negative 2. Well, remember when you plot a point, you first go to the right or left first. So I go to the right 3 and down 2, and yes, my point is on the line. So this is yes, or true. It is a solution to this equation. Now this equation is this line right here, and in future lessons we're going to be able to draw that line based on that equation. But even if we didn't have the graph to check to see if it was a solution, what you would do is, if the coordinate is 3, negative 2, that 3 represents my x value, and the negative 2 represents my y value. What I could do is replace the x and the y in my equation with the coordinates. So x is equal to 3 minus 3 times y is equal to negative 2 is equal to 9. It's just like when we were evaluating expressions before. To see if this is actual solution now that you've plugged them in, what you will do is you look at your equation on the left and right hand side separately. You will use your order of operations on each side. Now, the right side of this equation is equal to 9. There's nothing else to do with that. So we just want to see if the left-hand side of the equation is equal to 9 or not. Using your order of operations, so parentheses first. I see a set of parentheses, but I only see one number in it. That doesn't really mean parentheses. It means multiplication. So what I would have to do is multiply my negative 3 times my negative 2 first. So negative 3 times negative 2 equals positive 6. 3 plus 6 is equal to 9. Well, 9 equals 9. So it's true. That is a solution. Let's try another one. Do they want to know if negative 2 is a solution? Well, we can plot it, seeing how they have the graph here for us. Negative 2 is down here. It's not on the line. So no, it's not a solution. We can even verify this further by plugging it into the equation. Our negative 2 is an x, and negative 2 is the y. So we have negative 2 plus negative 2. We want to know, does that equal the positive 2 on the other side? Well, a negative and a negative, those are the same sign, so we'd have to add, and the bigger sign was negative 4. Does negative 4 equal negative 2? No, it does not. So that's why it's not a solution. So, how can you verify that an ordered pair is a solution to the equation using a graph? Well, if we're using a graph, then we need to see if, or we can, instead of see, sorry, I should probably say, plot the point. When I say plot the point, that means, find the x and y value and draw the dot. Plot the point, and if it's on the line, then it is a solution. How can you verify that an ordered pair is a solution to an equation using an equation? Well, then we plug the x and y values into the equation, and if the sides are equal, like the left and right hand side of the equation are equal, then it's a solution.